Unit 5 looks at combining functions, and the first lesson we're going to look at is the sums and differences of functions. So we're going to look at functions being added and subtracted. And so let's take a look at the warm-up. So given f of x equals negative x squared plus 3, and g of x equals negative 2x, write a, h of x equals f of x plus g of x, and b, m of x equals f of x minus g of x. So essentially what we're doing is we're going to replace f and g with the functions that are associated with it. So all I'm going to do here is replace f of x with negative x squared plus 3, and I'll replace g of x with negative 2x. And if I simplify this, what I end up with is negative x squared minus 2x and then plus 3. Okay, so that's what h of x represents. H of x looks at the sum of two different functions. One function is a quadratic, the other function was linear, and when you end up adding it together, you end up with another quadratic function. Okay, let's take a look at the next one. We're looking at m of x equals the difference between f and g. And so if I substitute in each of the functions, I have negative x squared plus 3 minus negative 2x. And try to remember to put brackets around any expression that you substitute in, especially when you are subtracting, so that you don't forget to change the signs. And so what you end up with is negative x squared plus 2x. Negative and negative make a positive, and then plus 3. Okay, so there we go. We've actually looked at adding functions and subtracting functions. Essentially, we looked at it algebraically, and as you can see, all we're really doing is combining the functions through the operation that's given. Okay, so why is this some valuable information? So let's take a look at a little introduction to combining functions and see where it can be applied in real life. So the sound produced when a person strums a guitar chord represents the combination of sounds made by several strings. The sound made by each string can be represented by a sine function. Okay, so that's one of the trig functions that you know. The period of each function is based on the frequency of the sound. So how often the sound is made represents the period of the function. Whereas the loudness of the individual sound varies and is related to the amplitude of each function. So depending on how loud each sound is, the amplitude of the function changes. So these sine functions are literally added together to produce the desired sound. So for a guitar, so let's say you're looking at the sound of a G chord played on a 6-string acoustic guitar. The sound that it makes can be approximated by combining the following 3 sine functions. So here's the first function, the second function, and the third function. And you'll notice that the period and the amplitude for each of these actually vary. The scales haven't changed, so it goes up to positive 30 and negative 30 in the vertical axis, and it goes from 0 to 0.1 on the horizontal axis for each one of these. And you'll notice that the period for the first one is much greater than the period of the last function, and the amplitude of the first one is much higher than the amplitude of the last one as well. And you can see that in those equations. So in order to make the sound of a G chord played on a 6-string guitar, the sound is actually approximated by adding the 3 sine functions together as follows. So if I actually take these 3 functions, the ones that we saw the individual graphs of earlier, what will end up happening is you end up getting a function that looks like this. Okay? And so this is what the sound of a G chord played on a 6-string guitar actually looks like. Okay? And you'll notice it is a periodic function. You'll notice that the shape does no longer looks like a sine function, because now what you've actually done is combine 3 different sine functions together. Okay, so this is one example of combining functions in the real world. Okay. So just as complex molecules are built from atoms and simpler molecules, mathematical operations can be used to build more complicated functions from simpler ones. So these are all the simpler, notice that we have simpler in quotations. These are all the simpler functions. So we have the trigonometric, logarithmic, rational, exponential, and polynomial functions. Those are all the functions you looked at in this course. And then you have the other functions like radical functions and absolute value functions. Those are some of the things that you might have looked at in a little bit of detail last year. But if you combine all these functions together, through either adding, subtracting, multiplying, or dividing, you get a new set of functions. Okay? So, the following is a list of operations that can be performed on functions to produce new functions. So, sum, so by adding functions together; difference, which looks at subtracting functions; product, which means you are multiplying functions; quotient, which indicates you are dividing functions; and composition of functions. This one's a little bit different. You're looking at a function within a function, so we'll look at this one in a little bit of detail in a couple of lessons. Okay? But today what our focus is on is just looking at the sum and difference of functions.